I recently did a teardown of this little pink USB blender. Now, by USB, I mean it recharges off the USB because it's got an internal battery. And this one was quite interesting because it had a safety feature that kind of screwed up on me while I was using it, demonstrated in the video. It's got some magnets down here in the plastic container, and I'd actually over-tightened it to the point that they were just slightly misaligned, and if you do tighten it too far, it just flashes a warning signal and it won't operate. Once I discovered that, I've actually had a lot of use out of this. It's great for making milkshakes and things like that, hot chocolate, but actually doing it cold and then heating the microwave after you've blended the milk together with the drinking chocolate. However, there's another one, and it's worth taking a look at. And the most exciting thing about this one, well, for a start, it's got a glass container, which is interesting. It's going to make it sort of more resilient, I suppose, to, well, it's not going to make it resilient if you drop it. But the main feature, apart from, oh, there is another feature, it's got a USB outlet for charging your phone. But the most important feature of all is the fact it has no safety interlocks in this razor sharp blade at all. So you can actually, if you were cleaning this, you can actually just turn it on. That's not good. So I've done some tests on the USB port in this, and it can supply 5 volts at about 1 amp before the voltage starts falling off. But even at 2 amps, the voltage drops down to about 4.5 volts, so it's capable of a modest amount of current. There's a quirk with this. Now, when it arrived, I, just pushed the button, and this didn't happen because it was completely flat. And by flat, it turned out that the lithium cell inside was well below its minimum voltage. It was below 3 volts, dramatically below 3 volts, closer to 0 volts actually. I get the feeling when I plugged it into charge, it started taking a charge at a really super low current, just trickling. And it was just going into battery recovery mode. And at that point, I opened it up and found the voltage across the battery was really low. So that's not a good thing. I've also discovered what I could describe as a software error. Now, these things usually have an interlock device whereby, they monitor the load in the blade. And if you actually operate it without a load, watch this. It runs for a while, and then it detects there's no load, and it cuts off. I think that's partly to prevent bearing damage, and it's also maybe a safety feature, I'm not really sure. I think your fingers would be mince in the 5 seconds or so it takes to do that. But the really annoying thing is there's a little green LED in there. See it flash on and off? This one does the same thing, but it flashes the LED about 5 times and then shuts down. This one just keeps flashing. The processor stays active, and it just keeps flashing that LED all the time as far as I can see. It doesn't seem to have the facility to say, shut off until you push the button. So let's open this up, and to be honest, to open this up I'm going to screw it into this because there's a very good chance I'm going to put my hand around the front of it while I'm unscrewing the screws in the back. So let's get into this. Other things, well, the first thing I noticed about this, possibly this flashing thing is drawing excessive current in standby. The thing I noticed was, when I got this, I did charge it up. I think I charged it fully, but then when I went to use it, it just seemed really sluggish. It just didn't seem as gutsy as the other one. And then I charged it again. It took a significant charge again. So either the battery is damaged and it's gradually draining itself, or the circuitry is imposing a parasitic drain. It might be because of that timer function. So what I'm going to do with this one, unlike the other one, I'm actually going to disconnect this because, let's just cut the wire. Let's just cut the battery out completely while I take this apart because it's just a little bit dangerous with that blade sticking out the front. Having said that, the other one did manage to take a divot out the bench while I was putting it together because it detected the magnetic field in the motor, I think, when I was putting it in, and that sort of mistriggered it and made it actually run when I pushed the button accidentally. So this one's a lot simpler. It looks very, very similar to the other one. Am I going to go into a huge long teardown this? I'm not so sure. It's interesting enough. I think, yes, you know what? I will do a sort of modest trace of the circuitry. It will be very similar to the other one. It's got a big MOSFET here to switch the motor. It's got the sense resistors, two 0.01 ohm sense resistors in parallel. So that's quite a low value. That's 0.005 ohms effectively. But the current is high enough in these things that it will produce enough of voltage for the chip to detect it. And I'm guessing that's the main chip there. And this chip here is probably, I'm just going to read this with a little magnifier if I can get close enough. 5056. Says 5056 1611. I'm guessing that's to do with this little inductor here, and it's the power supply, effectively the USB power supply function. So I'm going to pause for a moment. I'm going to take a closer look at this and see if I can see much and get any other numbers off this. I've kept this as modular as possible to keep it uncluttered. It's using a 5056 charge control chip, which is very similar to the 4056, the TP4056, which is extremely common. You can get little boards off eBay just for building your own controller chargers with it. So the USB in comes in, goes through that chip and charges the lithium cell. The charge control chip can also signal over to the little processor, the mystery processor with no marking. And the USB output side, the number of that chip, there's a tiny little chip just stuffed down in there. I had to actually cut the pins away on this connector to actually even read it. And it's called a TH5J3. And this is just it looks like a little 6-pin package, and that's all that's written on it. And I haven't a clue, but it's basically controlling the inductor, and it's dedicated to the task of USB out, and that's it, putting a 5-volt supply out in this connector here. The processor, this is very similar to what is in this pink unit. It's the processor controls the MOSFET via just a 1K resistor and then a resistor to the sort of negative rail just to make sure that the MOSFET turns off properly. And it's got 2 sense resistors, and when it switches the motor, it can measure the voltage across this because the processor chip has obviously got an analog input that it can just measure the voltage that goes up in that. So the higher the current, the higher the voltage it will detect, and that's how it detects, firstly, when it's off load, and because it's just detecting the motor running but there's a very low load, and it also detects when it's being overloaded and will shut off and flash a warning. The motor has a reverse polarity diode just to shunt any back EMF spikes. The 2 LEDs, the red and the green one, have a common 1K resistor going to the chip. The button just goes straight to the chip. That's really all there is to it. It's not that complicated a circuit. But it does have little software issues. Quiescent current is not great at 0.6 milliamps. I mean, it's supposedly a 2 amp hour lithium cell. And if it goes into standby, if the button gets pressed and it does that thing where it runs the motor, and then it cuts off and that green LED keeps flashing, the active circuitry consumes about 3 milliamps continuously, which would mean that if this was in storage and that button got pressed, as may have happened with mine, it could have happened in the shipping. All it takes is the box being squeezed to actually trigger that. Then it would have basically just trickle drained the battery continually, and in the space of about 3 weeks the battery would be pretty much flat. I don't know if that's what's happened. I don't know if that's why the battery was completely flat. I'm always wary once these batteries have been discharged below the 3 volt level or 2.5 volt level about the charging of them again, but it seems very common. Many of the Poundland cheapo chargers come with either the batteries with some charge in them, and for some odd reason those particular packs, the capacity of the cell isn't that high, or they come with the lithium cell completely flat, like 0 volts. And if you didn't know any better, you just plug it into charge, and it will slowly recover that at low current, and then once it reaches about 3 volts, it will then boost the current up to the full charging current. So it is, it's basically recovering the cell from flat. The ones in the Poundland little chargers are recovering to typically about 1 amp hour each, and they seem to deliver that on each full charge and discharge cycle. It's very odd. I wonder if they've somehow resolved the over discharge issue in lithium cells, or it's just more a case of it causing loss of capacity over time when that's done. I'm not really sure. So I'm not going to reassemble this one because this is just too dangerous. The fact that, if you're cleaning it and you accidentally press that button, it can start and it can blend your fingers. It would be so easy to do. That's a shame because it does have the glass container, but that's also a slight downside. Because with the little pink one, you can detach the lid off the top, and notice, by the way, that it tends to go a bit yucky underneath the seals. You have to take them out on a regular basis and clean them if you're using it a lot. And it's got this strainer for like sieving out the lumps of fruit if you're making smoothies in it. But one of the nice things about the pink one is that you can screw this straight on to the top without that sieve, and it just makes cleaning a bit easier if you're making something like a milkshake. The green one doesn't allow that. If you try to put the glass jar into that on its own, it doesn't quite seal properly, and it leaks everywhere when you use it. I'm not going to tighten that any further because it is kind of glass and it feels a bit plasticky and poppy and ugh. So yeah, it's odd. You know, this one's got a safety feature, this one doesn't have the safety feature, but this one seems better quality in the sense it's glass, but then, you know what, if you dropped it then it's going to smash. So I have to say, if you look, and if you're buying one of these and you see the one with the USB out, oh, that's another thing. This one at least makes an attempt to make this waterproof with a little rubber cover. It's not great, but it's better than nothing. This one doesn't, and if you splash it, if you give it a clean and it slops over, water goes in the USB ports, and that's not a great thing, is it? So, yeah, my vote's still with this little basic sort of pink one with the safety interlock. It just seems better electronically, and it just seems just a lot safer. So yeah, worth taking apart though. Always quite interesting to see what's inside these things and their little quirks, finger chopping quirks in this case.